How did the object go from an anti-tail to a tail to a no tail to an anti-tail to whatever it is?
The second possibility is that they might be thrusters on the technological spacecraft.
Only 3 interstellar visitors have ever been confirmed in our solar system, and one of them just grew a striking new tail. In a fresh image highlighted by Space.com, the interstellar comet 3I Atlas shows an ion tail that has suddenly become longer, sharper, and more dramatic. A visible sign that this traveler from another star system is really waking up near our sun. If you've been following 3I Atlas as that maybe comet, maybe something weirder object, this new tail is a big reality check. It's behaving exactly like an active comet being blasted by sunlight and solar wind. And that is great news for science. So what does a fast-growing ion tail really mean? And what can we actually learn from it? The new image was taken by the Virtual Telescope project in Italy, using a robotic telescope that stacked 18 separate 2-minute exposures, captured on the night of November 10th to 11, 2025. Even though the comet was just about 14 degrees above the horizon, with a bright gibbous moon not too far away, the photo still shows a bright nucleus, a compact coma, and a long razor-like ion tail stretching across a large slice of sky.
We see more than 7 jets that are tightly collimated coming out of this object.
Reports note that the tail is not only longer, but also more structured than in earlier images, clearly revealing a classic cometary ion tail pointing away from the sun, plus a faint anti-tail that appears to point in the opposite direction because of viewing geometry. In other words, this is not just a pretty picture. It is a snapshot of a rare interstellar comet entering a very active phase, with its chemistry and interaction with the solar wind now on full display. 3I Atlas, also catalogued as C2025N1 Atlas, was discovered in July 2025 by the Asteroid Terrestrial Impact Last Alert System Survey in Hawaii. Its orbit is hyperbolic, meaning it is not bound to the sun. It flew in from deep interstellar space and will leave our solar system forever after this single pass. Observations show that 3I Atlas is moving through the inner solar system at well over 200,000 kilometers per hour, making it one of the fastest comets ever recorded. It is only the 3rd confirmed interstellar object, after 1I Oumuamua in 2017 and 2I Borisov in 2019. But unlike Oumuamua, it clearly behaves like a comet, with a coma, dust, and now a bright ion tail. That combination, interstellar origin plus classic comet activity, is why scientists are so excited about every new image. The Virtual Telescope and Space.com coverage both emphasize how much the ion tail has changed in a short time. Earlier in its approach, 3I Atlas showed only a stubby tail and a small, hazy coma. Now the ion tail stretches farther across the sky and is finely collimated, like a narrow beam of charged gas. The new image also hints at a faint anti-tail, a feature that appears to point toward the sun. That is not anti-physics. It is a trick of perspective that happens when we are looking along the thin sheet of dust left along the comet's orbit. Together, the sharpened ion tail and emerging anti-tail tell astronomers that the comet's activity has ramped up significantly. More gas, more dust, and more interaction with the solar environment. If it can change this much in just a few days, you have to wonder what it will look like as it recedes from the sun but continues to outgas. When 3I Atlas gets closer to the sun, sunlight heats its surface and interior, causing volatile ices to sublimate straight from solid to gas. That gas escapes into space as a coma, carrying dust grains and molecules such as carbon dioxide and possibly carbon monoxide with it. Solar ultraviolet radiation then strips electrons from some of these molecules, turning them into ions, electrically charged particles. The solar wind, a stream of charged particles flowing outward from the sun, grabs those ions and drags them into a long, straight ion tail that always points away from the sun, regardless of which direction the comet is moving. Because the solar wind is fast and the ionized gas is so light, ion tails can grow and reorganize quickly. A modest increase in outgassing can translate into a visibly longer, brighter tail in a short time window. That is exactly what we are now seeing with 3I Atlas. A fast-growing ion tail is not just a cosmetic upgrade, it is a diagnostic tool. The brightness and structure of the tail carry information about how much gas the comet is ejecting, what that gas is made of, and how it interacts with the solar wind at different distances from the sun. Early infrared and space telescope observations suggest that 3I Atlas may be unusually rich in carbon dioxide ice, wrapped in a kind of irradiated crust that has been processed by cosmic rays for millions or even billions of years in deep space. If spectroscopic follow-up of the tail confirms a high carbon dioxide fraction or reveals other unusual species, that will tell us something about the protoplanetary disk where this comet originally formed, a disk around an entirely different star. And because 3I Atlas is brighter and more accessible than Oumuamua ever was, we can combine images of the tail, spectra of its gas, and even in situ measurements from spacecraft that may cross its ion tail. 3I Atlas could easily end up as the best characterized interstellar comet in history. Whenever an interstellar object grows a tail or behaves in a surprising way, the internet fills with speculation about alien spacecraft and controlled maneuvers. Commentary around 3I Atlas has already tried to push that narrative, echoing earlier debates about Oumuamua. But the mainstream scientific view, and NASA's own experts, are very clear. 3I Atlas behaves like a natural comet. Its brightening near perihelion, the emergence of jets, and now a strong ion tail are exactly what you would expect from an icy body getting closer to the sun. If anything, the new image strengthens the natural comet interpretation, because ion tail physics is well understood, and nothing about this behavior requires exotic explanations. The real wonder here is not that it might be alien technology. It is that ordinary physics is letting us read the chemistry of a world born around another star. The story does not end with one image. Spacecraft around Mars and Jupiter, including European and American missions, are being lined up to watch 3I Atlas and possibly even sample its extended ion tail as it sweeps through the inner solar system. Models show that a mission like Europa Clipper could cross packets of charged particles peeled off the comet by the solar wind, providing a unique, indirect taste of interstellar material. Meanwhile, ground-based observatories and projects such as the Virtual Telescope will keep imaging the comet as it moves away from the sun, tracking how the tail length, brightness, and shape evolve with time. For backyard observers with decent telescopes and dark skies, 3I Atlas should remain a challenging but rewarding target, especially as the ion tail continues to grow and drift across the pre-dawn sky. Will the tail keep stretching farther, or start to fragment and twist as the solar wind fluctuates? That is one of the key things astronomers hope to catch in real time. This new image of 3I Atlas, brought to wider attention through Space.com and the Virtual Telescope project, marks a turning point in our view of this interstellar visitor. A once faint speck has become a fully active interstellar comet with a long, bright ion tail, an anti-tail, and a complex interaction with the solar wind, all of it visible from our own backyard planet. As more observatories and spacecraft join the watch, every new photon from that tail carries clues about how comets form around other stars, how they survive billions of years in deep space, and how common our own solar system's building blocks might be in the wider galaxy. 3I Atlas may only visit once, but thanks to images like this, it is leaving behind a detailed chemical and dynamical postcard from another solar system.